Hey everybody, let's spend a little bit of time talking about a significant figure and what it is. And so in science, we have a reason that we may want to talk about numbers and how long of an answer we end up having. So we may have an answer that has 12 digits, but only a certain number of those will be important for us scientifically. And those digits, or those figures, we call significant figures. So before we talk about significant or not significant, let's spend a little bit of time talking about the two different types of numbers. Okay, there are two different types of numbers that we deal with when measuring things in science. There are exact numbers, and then there are measured numbers. Okay, now exact numbers are things like when you count something. So if I go around and I count how many people are in a class, that'll be like 1, 2, 3, 4. Any exact number have an infinite number of significant figures. Other cases of exact numbers are things like constants. And the famous example is something like pi. Pi goes on forever and ever, and because it goes on forever and ever, we have an exact number, and it has an infinite number of significant figures. But then there are values like measured numbers that we get in the class, like a length. And so a ruler will only give us a certain number of digits, a certain number of numbers that are significant in its measure. So if we get a number like 7.33 centimeters, and all numbers should come with a unit, we have 1, 2, 3 significant figures or significant digits in the number. Okay? And so that value, that number of significant digits is important in science because when we do math with these values, these digits can only play a big role into how we calculate numbers. Okay, so there's a blank slide, I don't know what that is. Okay, now, the problem comes in not when, here, let me go back to my, not when we have numbers like this, like we have 12, okay. Each of those we measured or we even counted, and each of those are significant. Okay? Or even when we have, like I said before, 7.33 centimeters, again, each one of those values, each one of those digits, we measured, and so we know that this number has 3 sig figs. What ends up happening is when we have a number like 15.0, is that 0 significant? Or if we have 100, are those zeros significant? And so is this a 3 significant figure number, or is this a 2 significant figure number? Is this 1, or is this 3? Okay, and so that's what we have to do. There are basically 3 types of zeros. Okay, and like the title of this slide implies, these zeros are tricky, can be tricky sometimes, okay? So there are zeros that are in front of, okay, in front of the first non-zero, okay? That's what we mean by leading zero. This can be confusing because a lot of people will put a leading zero and they'll say, oh, that's not a leading zero. Or they'll say that this is a leading zero even though it's behind the first non-zero. So here's the thing. A leading zero is in front of the first non-zero. And leading zeros are never, ever, ever significant. Okay? So this number, 0.003, has 1 significant figure. And now we can talk about sandwich zeros or zeros that are in between 2 other non-zero significant figures. So we have 2 non-zero significant figures. So we're looking at this 0 right here that I'm pointing at in red. And that 0, since it's between 2 non-zero digits, that is always going to be significant. Okay? So, here's the thing, is that we have a case where we have never significant, we have a case that is always significant, and so now we need to talk about trailing zeros, or zeros that occur after the last non-zero digit. And there's a whole bunch of these because we may have a number like 30. Okay, and so we're not counting counted numbers. We're talking about numbers that were measured. So if I take out a ruler and I measure 30, does this number, how many sig figs does this number have? Is that zero significant? Okay, so for trailing zeros, it's sometimes. And the sometimes is only dependent on one thing, and that's whether there is a decimal or not. Okay. So this zero right here, let me erase this so it's a little easier to see. This zero right here is not significant. It's a trailing zero. It's behind the last non-zero digit, but there's no decimal point in the number. I don't care if it's decimal anywhere in the number. There is no decimal in the number, therefore that zero is not significant. So this has one significant figure. Here we have 0.30, and so now we want to know, is that zero significant? Okay, again, it's a trailing zero. We already know that this zero is not significant because it's a leading zero. But this zero here, is it significant? Well, it is, because it is a trailing zero. It's a zero behind, it's behind the last non-zero digit, and there is a decimal point there in the number. It doesn't matter where the zero is, regardless, in respect to the decimal. It just matters that there is a decimal in the number. So now we look at this one, and this is where kids get the most confused. This has two significant figures. Why? Because we have a zero. So this is a trailing zero, and there's a decimal point in the answer in that number. So that makes that zero significant. So that is 2 sig figs. Okay. When we're dealing with numbers in scientific notation, or numbers that are very big and very small, it allows us to get rid of insignificant zeros. So here's a number, 3.2. And then if I were to write this in scientific notation, it's going to be 3.2 times 10 to the 7th. Now, are these zeros significant? They're trailing zeros with no decimal point. So when we write a number in scientific notation, we write the significant zeros in there. So this has no significant zeros, and so this has 2 sig figs, and then this has 2 sig figs. So scientific notation is a really easy way for us to determine whether we have significant zeros or not. So here's a number that I'm going to write in scientific notation, 10 to the minus 1, 2, 3, 4. And now these zeros we get are not significant because they're leading zeros. But what about this trailing zero? Because there's a decimal there, this zero is significant. So I'm going to put the 0 in right there. And now notice this has 3 significant figures, and when we write the number in scientific notation, that has 3 significant figures. So scientific notation will always write all the significant zeros, no matter what. Okay, so if it's a number in scientific notation, we don't look at the power or the exponent. We just look at the number in front and how many numbers are there, 0 or no 0. Okay, so that's all of scientific notation. Have a great day.